Hello everybody and welcome back to another video. In this video, I will be covering vector math. However, I will not be covering this type of vector math that I did in the other video where you add these two vectors and you get this vector. No arrows in this video because we cannot represent a four-dimensional object with arrows. So our work will be purely mathematical and no visual pictures really, unless you could visualize a fourth dimensional vector. However, you could think of it as if these three are spatial dimensions, so they're your position in space, and then this is the time dimension. If you really wanted to try to visualize it, you could also just think of it as this is how many oranges you have, this is how many apples you have, this is how many bananas you have, this is how much fish you have, whatever you want to think. However, in this video, the math is quite simple, so you do not need a heavy visualization. If you remember from the other vector video, if you add one vector to another vector, then you add their horizontal components, for which this one has none, and their vertical components, for which this one has none and this one has a lot, and you get a vector which has this length and this vertical quality, and if this had a bit more of a vertical quality, then this is the initial vector, this would look like this more. So in this video, we will be using that same concept of adding the same direction. So we will be adding this part and this part, and this part and this part, and this part to this part, because they represent the same thing in both vectors. Now in this case scenario, our vectors u and v are within a fourth dimensional, or have four parameters pretty much. Now, for this first problem, we will first rewrite u. And then I will rewrite v. And now we will just be adding our 0 to this part, our 7 to this part, our 9 to this part, and our 4 to this part. And we get 3, 16, 17, 11. And that is our answer for our vector x. It is as simple as that. You just add these parts because they share the same units and dimensions. Now, for our second problem, it is more difficult. As first, let's rewrite our vectors. For this one, you have to, the u vector was 3, 9, 8, 7. V vector is 0, 7, 9, 4. For this, you have to multiply them by a scalar first. So this will be multiplied by 3, and then this will be multiplied by 4. 3 times 3, that is equal to 9. 3 times 9, that is 27. 3 times 8, that is 24. 3 times 7, that is 21. Plus 4 times 0 is 0. 4 times 7 is 28. 4 times 9, 36. 4 times 4, 16. Forgot to write that in red, but it doesn't matter. I gotta rewrite it down here anyway. Now we add them again. And we just add downwards. So 0 plus 9 is 9. 27 plus 28 would be have to think about that. 55. This would be 60. And then 21 plus 16, that would be 37. So this right here is our vector y, and that is our answer. Now this concept, as of right now, as how far we are into it, does not have much math required. It's quite simple as long as you understand what you're doing. You just can't add, let's say you wanted to add a 3-dimensional and a 4-dimensional. That just doesn't work. They are not in the same, they do not have the same parameters, the same amount of parameters. Let's say that this 3 represents position and this 3 represents pizza. You cannot add these two vectors together. They have to have the same parameters in this space. I hope you enjoyed this video. Thank you for watching. Please like and subscribe, and I'll see you in the next one.